melted grounded, also known as a neutral, wire at the bus in a 200 amp residential panel on a 120 volts 15 amp branch circuit can be attributed to several potential causes. 1. Overcurrent. A sustained overcurrent exceeding the circuit's rated amperage can cause the grounded wire to overheat and melt. This could be due to overloaded circuits, faulty appliances, or short circuits. 2. A loose connection. A loose connection at the bus can create resistance and generate heat. Over time, this heat can weaken the wire and cause it to melt. 3. An arc fault. An arc fault, which occurs when electrical current jumps across a gap, can create intense heat, potentially melting the wire. This can be caused by damaged insulation, poor wiring practices, or loose connections. 4. A ground fault. A ground fault occurs when a live wire accidentally comes into contact with the grounded wire. This causes a high current to flow through the grounded wire, potentially melting it. 5. Corrosion. Corrosion on the grounded wire or at the bus connection can create resistance, leading to overheating and melting. 6. A failed circuit breaker. A faulty circuit breaker that does not properly trip when an overcurrent occurs can allow too much current to flow through the circuit, causing the grounded wire to melt. 7. Faulty wiring. Incorrectly sized or installed wiring can lead to overheating and melting of the grounded wire. Other potential factors include the age of the wiring. Older wiring may be more prone to insulation breakdown than corrosion. Circuit load can also play a part, as a high load on the circuit can contribute to overheating of the grounded wire. Ambient temperature is also a factor. High ambient temperatures can increase the resistance of the grounded wire, making it more susceptible to overheating. To elaborate on overcurrent, consider that each circuit is designed to handle a specific amount of current, measured in amps. The circuit breaker is sized to protect the wiring from overheating if this current is exceeded. When you plug in too many devices on a single circuit, or if a device malfunctions and draws excessive current, an overcurrent condition occurs. This excessive current flows through the wires, including the grounded wire, causing them to heat up. If the overcurrent is sustained, the heat can become intense enough to melt the insulation and eventually the wire itself. The melting point of copper, the material commonly used in electrical wiring, is about 1984 degrees Fahrenheit or 1085 degrees Celsius. However, the insulation around the wire typically melts at a much lower temperature. A loose connection increases resistance to the flow of electricity. Electrical resistance is the opposition to the flow of electric current in a circuit. The higher the resistance, the more energy is converted to heat. In a properly tightened connection, the contact area between the wire and the bus bar is maximized, minimizing resistance. However, when a connection is loose, the contact area is reduced, increasing resistance. This increased resistance causes the connection to heat up, and this heat can spread to the surrounding wire, potentially causing it to melt over time. Arc faults are dangerous electrical discharges that can ignite flammable materials and cause fires. They occur when electricity jumps across a gap between conductors, creating a high-temperature arc. This arc generates intense heat that can quickly melt the insulation and the wire itself. Arc faults can be caused by damaged insulation, loose connections, or corrosion. Standard circuit breakers are not designed to detect arc faults. However, arc fault circuit interrupters are specifically designed to detect and interrupt arc faults, providing added protection against electrical fires. A ground fault occurs when a live, ungrounded wire comes into contact with a grounded object, such as a metal enclosure or a grounded wire. This creates a low resistance path for current to flow back to the source, resulting in a high current flow through the grounded wire. This high current can quickly overheat the grounded wire and cause it to melt. Ground fault circuit interrupters, GFCIs, are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock and fire hazards. Corrosion is the gradual destruction of a material, usually a metal, by chemical reaction with its environment. In electrical systems, corrosion can occur on wires and connections, especially in damp or corrosive environment. Corrosion increases resistance to the flow of electricity, causing the affected area to heat up. This heat can weaken the wire and cause it to melt. Regular inspection and cleaning of electrical connections can help prevent corrosion. A faulty circuit breaker can fail to trip when an overcurrent occurs, allowing excessive current to flow through the circuit. This can happen if the breaker is damaged, worn out, or improperly sized for the circuit. Without the protection of the circuit breaker, the wiring can overheat and melt. Circuit breakers should be tested periodically to ensure that they are functioning properly. Incorrectly sized wiring can also lead to overheating. Electrical codes specify the minimum wire size for different circuit capacities. Using wiring that is too small for the load can cause the wire to overheat, even if the circuit breaker is properly sized. Over time, this overheating can degrade the insulation and eventually melt the wire. It is important to consult electrical codes and qualified electricians to ensure that wiring is properly sized for the intended application. The age of wiring can also contribute to its failure. Over time, the insulation on wires can become brittle and crack, exposing the conductor to moisture and corrosion. Older wiring may also have been installed using outdated methods and materials that are not as safe as modern wiring. It may be necessary to replace older wiring to ensure electrical safety. A high circuit load can also contribute to overheating. A circuit's load is the amount of current that is being drawn by the devices connected to it. If the circuit is consistently loaded close to its maximum capacity, the wires can overheat, even if the circuit breaker is properly sized. It is important to distribute the load evenly across multiple circuits to prevent overheating. High ambient temperatures can also increase the resistance of the grounded wire. The resistance of a conductor increases with temperature. In hot environments, the resistance of the wiring can increase significantly, leading to increased heat generation and potentially melting the wire. It is important to ensure that electrical panels are properly ventilated and not exposed to excessive heat. Several steps can be taken to prevent a grounded wire from melting. Firstly, ensure proper circuit loading. Avoid overloading circuits by distributing the load evenly across multiple circuits. Use a circuit analyzer to measure the current draw of each circuit. Secondly, use quality wiring and connections. Use high-quality wiring and connectors that are rated for the intended application. Ensure that all connections are tight and properly torqued. Thirdly, inspect wiring regularly. Inspect wiring regularly for signs of damage, corrosion, or overheating. Replace any damaged or corroded wiring immediately. Fourthly, install arc fault circuit interrupters. Install a size to protect against arc faults, which can cause fires. Fifthly, install ground fault circuit interrupters. Install GFCIs to protect against ground faults, which can cause electrical shock and fire hazards. Sixthly, test circuit breakers. Test circuit breakers periodically to ensure that they are functioning properly. Seventhly, improve ventilation. Ensure that electrical panels are properly ventilated to prevent overheating. Eighthly, consider professional inspection. Have a qualified electrician inspect your electrical system periodically to identify and address any potential problems. Remember that working with electricity can be dangerous. If you are not comfortable working with electrical systems, always consult a qualified electrician. Electrical safety is paramount. By following these guidelines, you can reduce the risk of a melted grounded wire and ensure the safety of your electrical system. Understanding the underlying causes, such as overcurrent, loose connections, and environmental factors, is crucial for effective troubleshooting and prevention. Implementing these preventative measures helps maintain a safe and reliable electrical system in your home or building. Additionally, consider the specific characteristics of the branch circuit in question. Is it frequently used? Are there any known issues with the appliances connected to it? Are there any recent electrical modifications? These details can provide valuable clues in identifying the root cause of the problem. Remember that a melted grounded wire is a serious issue that should be addressed immediately by a qualified electrician. Ignoring the problem can lead to further damage, electrical shock, or fire. Proper maintenance, regular inspections, and adherence to electrical codes are essential for ensuring the safety and reliability of your electrical system.